Okay, I'm going to explain a couple things about polynomial functions. So I'm pretty sure everybody knows that this is a parabola. It's y equals x squared. I kind of want to show a little pattern here. This right here, that could be the graph of y equals x cubed. If we go like this, y equals x to the fourth. Just going to do a few more of these. Okay, so you might notice, there might be some things you're going to notice here. One of the things I hope that you would notice is that when it's y equals x squared, if I were to draw a, I don't know, an x-axis right here, let's say that's the x-axis, how many roots or how many zeros could I possibly have? 2, right? It could cross the x-axis. If I had an x-axis and it hit it just right, it could have as many as 2 roots. This is cubed, and if this is an x-axis, I could have 1, 2, up to 3 roots, right? Notice something about the exponent? Okay, this one could have 1, 2, 3, 4 roots. Get the idea? 1, 2, 3, 4, 5. It could have up to 5 roots if that is the x-axis and it hits it just right. So 1, 2, 3, 4, 5, 6. Another thing I would like for you to be able to notice is that when you have the exponent is an even number, do you notice that the end behavior, the 2 arrows, they point in the same direction? In this case, they're all pointing up. See, there's x to the 4th, it points up, y to the 6th. So sometimes in your math book, you are asked to show like just to make up an example of a function. Like if they just said, hey, just draw a graph of a cubic, pretty much anything that's kind of curvy-like could do. But in the case of your test that you guys just took, you were asked to draw different polynomials with different numbers of roots. So for instance, one of the questions, it said it wanted 7 real roots. So that means you have to have some kind of polynomial that crosses the x-axis 7 times. So if you want 7 real roots, you'd have to draw maybe an x-axis, right, if this is y and this is x. And you'd have to just make sure the thing crosses 7 times. Well, so I think I'm going to have to, let's see, let's just start like this. I'm going to have to cross 1, 2, 3, 4, 5, 6, 7. It didn't say exactly how the graph had to look, but it wanted 7 real roots. So the real roots, I'm going to write real roots are the x-intercepts. Okay? This has 7 real roots. Now, sometimes things don't work out exactly how you plan. Like, sometimes, have you ever seen a parabola? This parabola, it has 2 real roots. But have you ever, maybe you were factoring a quadratic or something, and you had to put it in the quadratic formula, and then you ended up with some kind of parabola that was up here like this? Well, that's still going to have 2 roots, but none of those roots are going to be real. So this is going to have two complex roots. Okay, and the reason it's going to have complex roots is because complex roots come from when you use the quadratic formula and you get that little I you know you're going to have, I'll just write a little I. You get an I, you have a negative underneath your square root sign. So on these other, you're not going to be using the quadratic formula on any of these other types of polynomials, but I'm just trying to show, like there was a test question that you had where you had to have 5 real roots and 2 complex roots. I just want to give you an example of how you could draw something like that. Okay, so let's say you have a test question and it says draw a function with 5 real roots. 5 real roots and 2 complex roots. So if this was my test and I had to draw this function, I'm going to want to do it the easiest way possible. The first thing I'm going to do is add up all the roots, and I'm going to say, well, I got 5, 6, 7. That means I need to go draw one of these squiggly things, but it needs to have 7. So it's going to go like it's going to start up here and it's going to go no, but then it's going to go back down again. But then I have to be careful with it because I want 5 of the roots to be x-intercepts. So basically, it's not too hard to do. I can draw this. This is, here's my x-axis, here's my y-axis, and I just have to draw something that crosses the x-axis 5 times, and then it has 2 complex roots. So the way I would do it if it was my question is I would go 1, 2, 3, 4, 5, and you know how I have to keep going like up and down more times? I would just make sure I miss. Like right here I'm sorry, you missed that part. So I'd go 1, 2, 3, 4, 5, because I need 5 real roots, and then for the complex roots, I would show that it goes up and back down again. You know, maybe there's some complex roots, but I wouldn't let them touch the x-axis. Okay, so that's all I'm going to say about that, and I hope that helps you to draw these types of graphs.